In the previous lecture, we learnt how to find the approximate root of the algebraic and transcendental equations by using regular Falcine method. So in this lecture, I am going to find the approximate roots of the algebraic and transcendental equations by using Newton-Raphson method. So Newton-Raphson method is nothing. It can be used to find the real root of the nonlinear equations. The formula for Newton-Raphson method is given by xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So now we will see few examples related to Newton-Raphson method. The first example is use Newton-Raphson method to find cube root of 37 with 3 decimal places. So here the function we have to define first. So how to define function means, so let me choose x is equal to cube root of 37. So now taking power 3 on both sides of the above equation. So we'll get x cube is equal to 37. Shifting 37 to LHS, I got x cube minus 37 is equal to 0. So now I can take here that whole thing as a f of x. So I got it, f of x is equal to x cube minus 37. So according to the formula, we have to estimate f dash of x also. So from the given equation, I'm going to differentiate the given equation with respect to x. I will get f dash of x is 3x square. So now we have to find the x naught root to estimate the iteration. So for that, I am going to replace x is equal to 0, x is equal to 1, x is equal to 3, x is equal to 4 in the given f of x equation. So since getting the positive function, we have to do the process like this. So if I replace x is equal to 0 here, I am getting minus 37, which is less than 0. If I replace x is equal to 1, I am getting minus 36, which is less than 0. If I replace x is equal to 2, I am getting minus 29, which is less than 0. If I replace x is equal to 3, I am getting minus 10, which is less than 0. If I replace x is equal to 4, I am getting plus 27, which is greater than 0. So now we can observe here, at x is equal to 3, I got negative, at x is equal to 4, I got positive. So I can stop the process here. So now out of this minus 10 and plus 27, minus 10 is very near to 0. So therefore I can choose the root x naught is equal to 3, since f of 3 minus 10, which is very close to 0. So after finding x naught, we have to find f dash of x naught also. So f dash of x naught will be replacing the value of x naught in the f dash of x equation. I got it as 27. So now we will find iteration number 1. So iteration 1 is nothing. In the main Newton-Raphson method formula, xn plus 1 is equal to xn minus f of xn by f dash of xn. We have to replace n is equal to 0. So if I replace n is equal to 0 in the main formula, I'll get the equation like x1 is equal to x0 minus f of x0 by f dash of x0. So now if I replace x0 value, f of x0 value, f dash of x0 value in this equation, I can able to find the first approximate root x1. So on simplifying the above function, I got x1 is equal to 3.3703. So after estimating the value of x1, replace this x1 value in the f of x function, f dash of x function to estimate f of x1 and f dash of x1. So after replacing 3.3703 in the functions, I got f of x1 is equal to 1.282, f dash of x1 is equal to 34.076. So now I can find iteration number 2. So iteration number 2 is when n is equal to 1 in the main formula. So x2 is equal to, I can x1 minus f of x1 by f dash of x1, I got it. So replace x1 value, f of x1 value, f dash of x1 value in the formula. So on simplifying the equation, I will get x2 is equal to 3.3313. And iteration number 3. So in the iteration number 3, replace n is equal to 2 in the main Newton-Raphson method formula. So I will get x3 is equal to x2 minus f of x2 by f dash of x2. So if I replace x2 value along with f of x2 value and f dash of x2 value in the formula, on simplifying the above equations, we'll get x3 is equal to 3.3314. Now we can observe one thing here, up to 3 decimal places from in x2 as well as x3 it is same. So we can stop the iteration process here. So now we can conclude that approximate root of the equation, that is x cube minus 37 is 3.331, that is the value of cube root of 37 is 3.331. So we will see one more example related to Newton-Raphson method. The problem is like this. Using Newton-Raphson method, find the real root of the equation correct to 3 decimal places. The equation is cos x minus x into e power x is equal to 0, which lies near x is equal to 0.1. So which lies near x is equal to 0.5 is nothing but they have given initial condition of the equation, that is in this problem we have to choose x naught is equal to 0.5. And we can observe one thing, the equation is an transcendental equation. It contains trigonometric function mainly. So in regular falsy method also and here also, any equation contains trigonometric function like cos, sin, tan function, we must keep the calculator in the radian mode. So now we have to keep the calculator in the radian mode to compute the root of the equation cos x minus x e power x. So same thing here also. According to the Newton-Raphson method formula, we want f of x and f dash of x. I'm going to differentiate the f of x equation. So if I differentiate f of x equation with respect to x one time, cos x will be minus sin x minus x e power x is there. So since here two terms are there, we have to use the product tool. I am keeping x as it is, differentiating e power x, I will get e power x only, minus keeping e power x as it is, differentiating x, I will get 1. So I got f dash of x is equal to minus sin x minus x e power x minus e power x. So now we want f of x naught and f dash of x naught. So already they have given x naught is equal to 0.5. So in the f of x equation and f dash of x equation, I am going to replace x is equal to 0.5. So I got the value like f of x naught is equal to 0.053, f dash of x naught is equal to minus 2.95. So now I'm going to start the iteration. So in the first iteration, I'm going to replace n is equal to 1 in the main Newton-Raphson method formula. So if I replace n is equal to 0, I'll get the equation like x1 is equal to x naught minus f of x naught divided by f dash of x naught. So replace the values of x naught, f of x naught, f dash of x naught in the formula and simplify it. We'll get x1 is equal to 0.518. So after finding x1, we have to estimate f of x1 and f dash of x1. So replacing x1 value here. So I got f of x1 is equal to 0.105, f dash of x1 is equal to minus 2.86. So now iteration number 2 is, so replacing n is equal to 2 in the main formula. So if I replace n is equal to 2 in the main formula, I'll get the equation like x2 is equal to x1 minus f of x1 divided by f dash of x1. So if I replace all x1, f of x1, f dash of x1 and simplifying the equation, we'll get the value of x2 is equal to 0.5185. And we can observe here x1 and x2 are equal till 3 decimal places, that is 0.518 is common in both the iteration. So we can stop the iteration process here. We can conclude the value of x is 0.518. Thank you.